to day 30 of calculus. Today we're going to take a stroll through the park. Elaine is trying to get to the bus, and she can either walk through the park or she can walk on the sidewalk or some combination of the two. So she has 7 minutes until the bus leaves. The bus stop is across the grassy park, 2,000 feet east and 600 feet south. They give you a nice diagram too, which is super helpful. She can walk along the sidewalk at a speed of 6 feet a second. There's also the 600 there. She can also choose to travel through the grassy park at 4 feet a second, so it's slower if she goes through the park. What path will get her to the bus stop the fastest? Will she make it there in time? So we're trying to minimize time. So how long does it take her for time for the trip? And her time traveled is going to be whatever distance she spends on the sidewalk in time, plus the time she spends going across the park. We're also assuming she's going in straight lines. So let's call that distance x and that distance y. So if that distance is x and she moves at 6 feet a second, the time she spends on x is going to be x divided by 6. So 12 feet, 6 feet per second would be 2 seconds. But for y, it's y divided by 4 because she's moving slower when she moves through the park. Now, though, we'd want to take the derivative, but again, we're stuck because, like many times before, we can't take the derivative of that yet because it's in two variables, x and y. So we need a relationship between x and y. Well, we actually have another one because there's a right triangle here. There's this right triangle right here, right there. So we know this distance is 600 feet right there. And we know that this distance right here, the one right there, is going to be 2,000 feet minus x. So what does that tell us? It tells us that 2,000 minus x squared plus 600 squared will equal y squared. So what does that tell us? It tells us that y is equal to plus or minus the square root of 2,000 minus x squared plus 600 squared. Now she could go further and come back, but we know that that's going to burn more time. So we're going to assume she doesn't do that. We can now substitute y in right there, into our time equation, right there. And now we have time traveled in terms of x is going to be x over 6 plus the square root of this thing, which is, again, 2,000 minus x squared plus 600 squared all over 4. That is in one variable. That's in one variable, which is x. So we can take the derivative. We just have to take it carefully. So let's rearrange this a little bit. Let's rearrange this as, instead of x over 6, 1/6 x, just to see something nice here. And instead of square root, let's write it as to the 1/2 power. And dividing by 4, we can just put that 4 on the 1/4 on the outside. So it's like this, 1/4. And just for style points, let's move it down a little bit. So all I've done is simplify it a little bit before we take the derivative. So when we take the derivative now, we end up with t prime of x is equal to, well, we get 1/6 plus, and we're going to bring that 1/2 down to the front. So we still have the 1/4, but that 1/2 migrates down to the front. And then everything else stays the same on the inside because we haven't done the chain rule yet. 600 squared, and it's to the negative 1/2. And now we need the derivative of the inside. What's the derivative of this going to be? Because of the chain rule, it tells us it's going to be 2 times 2,000 minus x, all on the outside, times, we have to do the chain rule because it's the derivative of the inside there. So the chain rule happens twice right there. So we now have the derivative, and as we've done many, many times before, we need to use algebra to solve this or use our calculator. Use algebra to solve this or use our calculator. If you do this out with algebra, you end up with x is equaling 2,000 plus or minus the square root of 4/5 times 600 squared. You can also use your calculator directly to get both of these. So when you do this out, you end up with two answers, 2,536.656 or 1,463.344. Now one of those is doable and one of them isn't. If she goes 2,000, that means she's gone further than she needs to. She's gone back and then forward like over 2,000. She'd go like a little bit further in the back. So that's too far. So it's really going to be this for your x value. So we now know we could calculate how long it's taking by plugging all of this into the original equation up here. We want to know how long it's taking her. So we have x right now. If we wanted y, we need to plug in y, right? So we take this number and we plug it in right here. And then we also take this number and plug it in here so we can get the y value when x is that. The y value when x is that is 804.984, and you should verify that using your calculator. Now you plug that in right there. So we got the x value, and then we use the x value, plugging it in there to get the y value. So when you do this out, the time when x is 1,463 and y is 804, the total time will be 445, and that's going to be in seconds, which is equal to 7 minutes and 24 seconds. So is she going to be able to make the bus? She is not going to be able to make the bus. To recap, we wrote an equation for what we were trying to minimize. We needed it in one variable, so we needed the second relationship, which we solved for y and plugged in here. We then had an equation in one variable, which we took the derivative of to get this big derivative. If you simplify it and set it equal to 0, you get x equals 2,000 plus or minus the square root of 4/5 times 600 squared, and you get two answers. One of these is too big because she would have gone too far past there and come back, so we want to use the smaller of the two, which is 1,463, and that's going to be our x value. So once we have our x value, we use that to find our y value and plug it into our time equation, and then we end up with 7 minutes and 24 seconds. So she is going to miss her bus.